Hello student, welcome to my channel Kunal sir at JEE NEET Chemistry World. Today I am going to discuss very important topic for JEE and NEET, which is nothing but a balancing of a redox reactions. Balancing of redox reactions. Redox reactions we used to write down like R X N. Already in my previous video I explained very clearly which is called as a redox reaction. That means the reactions where the oxidations and reduction used to occur simultaneously, that reaction is called as a redox reaction. Red is coming from reduction, ox is coming from oxidation. By combination it is called as a redox reaction. Now, how to balance that redox reactions either in a acidic medium or in a basic medium? Within bracket I am writing acidic medium or it will be in a basic medium. That means either in reactant side or product side you should have a H plus or OH minus. Basic medium means OH minus, acidic medium means H plus. So now if we able to balance in acidic medium, basic medium will be done in 1 second. That's why first let us look at in a acidic medium, and this balancing of redox reaction can be done by two methods. One is, first method we will discuss, ion electron method, and second one we will discuss same reaction by oxidation number method. So ion electron method is little lengthy, but it will never going to give you any mistake. But oxidation number also will not give you mistakes if you know properly. But oxidation number method will be done in 1 second. So now these are the two methods for the balancing of a redox reaction. Let us take one reactions like KMnO4 react with ferrous sulfate in acidic medium. Acidic medium means dilute H2SO4. I am talking about these things is there your dilute H2SO4, and this gives rise to that manganese sulfate K2SO4 and Fe2SO4 whole thrice. But it is not a balanced reaction. So if you look at very clearly, they will give you reactions like this way, but or either they will give you like this way, or they will give you only by ion which is changing its oxidation state. Now potassium ion and sulfate ion is not changing its oxidation state at all during the course of the reaction. That's why they are spectator ion. The substance or the element of atom or the substance which is not going to change its oxidation state during the redox reaction is called as a spectator ion. So you reactant side and both product side, if you look at potassium oxidation state is +1 over here. Here also each potassium oxidation state is +1 over here into 2, and sulfate overall charge is -2. So always, that's why if you look at that sulfate and your potassium is not going to change its oxidation state. The substance which is not going to change its oxidation state during the redox reaction is called as a spectator ion. So that's why, who are the spectator ion over here? Spectator ion is nothing but your potassium ion as well as sulfate ion during this above redox reaction. Whenever they will give like this way, you have to write down the redox reaction by discarding the spectator ion. Actually, what I have to write down? I have to write down like that actual reaction, which is MnO4 minus, and here H plus also will not going to change its oxidation state. That's why H2SO4 will give H plus. So that is also will be there in the form of a water. So that's why its oxidation state will not change. So this all are spectator ion, and H plus also you can write down, and H plus also spectator ion. So now without the spectator ion, you have to write down the equation. Then without the spectator ion, I have to write down the equation, means then what are the things are changing oxidation state? MnO4 minus, where manganese is changing its oxidation state and iron is changing its oxidation state. So that's why without the spectator ion, you have to write down the equation like MnO4 minus plus, here iron oxidation state is plus 2 because overall sulfate is minus 2. That's why iron plus 2, and it is converting to, here manganese is plus 2 oxidation state, here iron is in, because you look at here iron is in plus 3 into 2, here sulfate minus 2 into 3. That's why overall substance is a neutral. So now manganese plus 2 plus iron plus 3. This is the reaction. If they provide you this one, you have to write down this one. And then you have to think about the balancing this reaction in a acidic medium. I am telling balance it in acidic medium. Balance it in acidic medium. Acidic medium. Now if you look at here, first you need to look at what is the oxidations happening and what is the reductions happening. So whenever the oxidation number is increasing, that is nothing but oxidation, because that is only will be happen when there is a loss of electron is there. And oxidation number decreasing means it's a reduction CO sort. Why? By gain of electron will be taking place, which results in a decreasing of a oxidation number or oxidation state. So now here manganese is there in a plus 7 oxidation state, and now plus 7 oxidation state is going to the plus 2 oxidation state. So that's why it is a case of a reduction. Oxidation number is decreasing. The substance which is undergoing reduction will act as a oxidizing agent. That means itself will go for a reduction, but it will oxidize the others by snatching the electrons. So now iron plus 2 is going to the iron plus 3, oxidation number is increasing. So that's why it is a case of a oxidation. The species which is undergoing oxidation, that means it is supply the electron to the others for the reductions. That's why it is acting as a reducing agent. This is acting as a reducing agent. First you identify this one, and then you separate the reaction. What is oxidation reaction? That is you write down. And what is reduction reaction? That is you write down. So now let us look at that thing in a next slide. So next slide, what we can write down? I am writing, you look at MnO4 minus is converting to Mn plus 2, and this is nothing but a reduction reaction. Here I am writing this is a reduction reaction. I separate which is reduction reaction and which is a oxidation reaction. So now here oxidation reactions also I separate like this. Oxidation reaction, iron plus 2 is converting to iron plus 3. Now you look at, we need to balance both the reactions and then we need to add it up. That is as simple as that. First we are doing a ion electron method balancing. This is the simplest. So now if you look at very carefully, manganese, both the side, how many? Here also one manganese atom, here also one manganese atom. So manganese perspective, no need to balance. So that's why here how many oxygen atom? 4. Opposite side come, and that many water you need to add over here. Generally oxygen is balanced by water. So that's why I write down 4 water molecule. Whenever I write down both the side, 4 oxygen atom is there, but here 8 hydrogen atom is there right side. So for that purpose, here I am writing 8H plus. Now you look at, because I need to balance in a acidic medium, that purpose I write down 8H plus. How many hydrogen in opposite side? Then that means product side, how many hydrogen over here? 8. then you reactant side you will write down 8H plus. If the H2 is there in a reactant side, then product side I need to write down that many H plus. Point is clear? Okay. Now you look at overall charge, both the side, reactant and product side will be equal. Conventionally, left hand side is a reactant side, right hand side is a product side. Now, if you look at how many electron, how I can write down? Just now I told you plus 7 oxidation state is going to the plus 2. How many unit change is there? 5 unit change. Or what is the N factor? Already in my previous video I discussed N factor calculation. Change in oxidation state into number of atom associated. Plus 7 is going to plus 2, 5 unit change. How many manganese atom? 1 manganese atom. So then N factor is 5 for this reaction. That many number of electron you will add, because the reaction is a reduction reaction. Gain of electron is a reduction. That's why MnO4 minus plus 8H plus 5 electron will be equals to Mn plus 2 plus 4H2. It's clearly balanced situation. Now, if you look at charge wise, both the sides same. Here you look at overall 6 negative and 8 positive, 2 unit positive. This side also 2 unit positive. Oxygen, hydrogen, manganese, all atom are balanced. Now come to the oxidations. Oxidation, iron is converting to iron plus 3. How possible? By loss of 1 electron. And now both the side iron atom is same, no need to balance that one. Now both reduction and oxidation separately they are balanced. Now the last important checking will be there. The number of moles of electron involved in oxidation process should be equal to the number of electron involved in a reduction process. Otherwise, electron is not a ghost. If they are not balanced, electron will not move out. Some species will lose the electron, same amount of electron will gain by other species. So that's why number of moles of electron involved in oxidation process should be equal to the number of moles of electron in a reduction process. Now you look at in reduction process there are 5 mole of electron, whereas in oxidation process there are 1 mole of electron. To make the equalize the number of moles electron involved in both oxidation and reduction process, the oxidation reaction, overall reaction I multiplied by 5. Now after multiplications, the oxidation reaction come into the picture. 5 Fe plus 2 and it is converting to 5 Fe plus 3 by loss of 5 electron. Now if you look at, if I give, this is my equation 1 and this is my equation 2 after multiplications, then add equation 1 and 2. Add equation 1 plus 2. Then what we will get? We will get, you look at 5 electron this side and this side 5 electron cancelled. Then what we will get over here? MnO4 minus plus 8H plus, reactant side what is there? Plus 5 Fe plus 2. And now I am giving equal sign and then Mn plus 2 plus 4H2O plus 5 Fe plus 3. 5 Fe plus 3. Now you look at the reaction is balanced in a which medium? Acidic medium. Why? In a reactant side or product side, it should have a H plus. So they told the reaction is to be balanced in a acidic medium. We balance it. Now, if you look at overall charge, manganese 1, manganese this side 1. Total hydrogen 8, here 8. 5 iron, everything balanced. Total charge you count, 5 into plus 3. Plus 15 plus 2 plus 17, 5 into plus 2 plus 10 plus 8 plus 18 minus 1. So that is nothing but a plus 17. Everything are balanced. Reaction is balanced in a acidic medium. If you want to do in a basic medium, then what you have to do? Same number of H plus, either which is there in a reactant side or product side, same number of H minus you need to add both the side. So then you add over here 8OH this side plus 8OH this side. Now if you look at very carefully, when you are adding that 8OH, 8H plus and 8OH minus will form a 8 water molecule. Then what will be my situation? MnO4 minus, this will form a water molecule. So 8H2O plus 5 Fe plus 2 will be converting to Mn plus 2 plus 4H2O plus 5Fe plus 3 plus 8OH minus. Now you look at your product side 4H2O, reactant side HH2O. If you bring this 4H2O this side, 8 minus 4, then your reactant side effectively there will be 4H2O. So then if I write down that equation after removing, MnO4 minus plus 4H2O plus 5Fe plus 2 equals to Mn plus 2 plus 5Fe plus 3 plus 8OH minus. Now reaction is balanced in a, this one is, you look at very clearly, this one is balanced in a basic medium. Why? In the product side OH minus is there, and this one initially this one was there. You look at this one was there, this is balanced in a acidic medium. Why? In a reactant side HH plus, 8H plus is there. So now this method you will never do mistake, but little lengthy method. What question they used to ask? They will give you this reaction like this, MnO4 minus XH plus and ZFe plus 2 equals to Mn plus 2 plus AH2O plus BFe plus 3, and then they will ask you X plus Z plus A plus B equals to how much. That way they used to ask the questions in JEE and NEET examinations. So now this is the way ion electron method, but we can do the same thing in oxidation number method. How? If you look at that one. So oxidation number method, if you used to do same thing will come. That means if you look at what you have to do, first you count that one, what is the N factor for this process. First you will separate out without spectator ion, you will write down. After writing that one, you look at what is the N factor for reduction reaction, what is the N factor for oxidation reaction. So here N factor will be equals to change in oxidation state 5 unit into number of manganese atom 1. So that's why N factor for here 5. Now here N factor you calculate. N factor for oxidations, change in oxidation state which is 1 iron atom associated. That means we got the reduction reaction N factor is 5 and oxidation reaction N factor is 5. Now make it crisscross. That means what is the N factor for oxidation reaction, that you write down before the MnO4 minus reduction reaction, MnO4 minus, and what is the N factor for reduction reaction, that you write down the oxidation reaction before the reactant. Then you write down 5Fe plus 2, and these will give rise to immediately, you know very well, acidic medium MnO4 minus will be converting Mn plus 2, that is there, and 5Fe plus 2 written, Fe plus 3 also will be there in 5, then only the number of iron atom balance. Now after that doing these things, you look at here extra 4 oxygen is there. For that purpose what I have to do, opposite side I have to write down that many water, and reactant side I have to write down the H plus. Water, hydrogen need to be balanced by H plus, and now reaction is balanced in a acidic medium. You look at same thing, we got it in ion electron method. You look at MnO4 minus plus 8H plus 5Fe plus 2 will be equals to Mn plus 2 plus 4H2 plus 5Fe plus 3. Same thing we are getting over here by oxidation number method in simple trick. Is it clear? Okay, let us look at another reactions and then we will bind up. So here they are giving a disproportionation reaction, like P4 is converting to PH3 plus H2PO2 minus. Now this reaction I need to balance out in a acidic medium. If you are able to do in a acidic medium, I show you basic medium, simple things you can do by yourself. So now this is a 0 oxidation state is going to the -3. Here phosphorus is a +1 oxidation state. So now one of the oxidation state of one element is going to the 2 different oxidation state. One is lower and one is higher. That is called as a disproportionation reaction. You look at 0 to phosphorus, -3 oxidation number decreasing. So then this is nothing but a which reaction? See, this is nothing but a reduction. Whereas same phosphorus is 0 to +1, this is nothing but oxidations. So now it is called as a disproportionation reaction. I am writing this. This means which reaction? Disproportionation reaction. If one of the oxidation state of one element is going to the two different oxidation state is called as a disproportionation reactions. So now you look at, first I told you same method, separate reduction reaction. Disproportionation reaction specialty is during n factor calculations also I told, one time you have to think P4 is converting to PH3, same P4 next time it is converting to H2PO2 minus, then only you can understood and balance the redox reactions. So now reduction, what is happening, P4 is converting to PH3. Obviously I have 4P is there, 4 phosphorus, by close your eyes I give you 4 PH3. When I am giving 4 PH3, this side there are 12 hydrogen. For that purpose, I am writing over here 12 H plus. And you look at zero oxidation state is going to the minus 3. That means each phosphorus is gaining 3 electron. 4 phosphorus atom is there. That's why there will be 12 electron gain will be there. Now it's a balanced reaction. You look at hydrogen balance, phosphorus balance, overall charge both the side is balanced. 12 positive, 12 negative, everything is balanced. Come into the oxidations. Oxidations reaction, what again you have to think, P4 is converting to H2PO2. Now here 4 phosphorus is there. Close your eyes, this side first you put 4, overall charge is minus. Now if you look at over here, 4 into 2, this side 8 oxygen is there. Then immediately to make a equal, here I am taking 8 H2O. You look at, I am taking a 8 H2O. When I am writing this side there are 16 hydrogen, but this side 8 hydrogen. That's why I have to write down this side 8 H plus. Yes or no? That side I write down 8 H plus. Now if you look at here, each phosphorus is going to the oxidation change. If you look at, each phosphorus is losing 1 electron. There are 4 phosphorus is there. That's why if you look at it, it is losing how many electron? Each phosphorus is 1 electron. 4 phosphorus is 4 electrons. 4 mole of electron is losing. Now if you look at this side, 4 phosphorus, product side also 4 phosphorus. There are 18 hydrogen. Here are also 18 hydrogen. Oxygen is 8. Oxygen is 8. What about overall charge? Here 4 minus is, if you look at the overall charge over there, here 4 minus, 8 minus and 8 plus, overall neutral. This side also overall neutral. Now it's a balanced reaction. Now the question is that overall, if you look at overall number of moles, I told you the last checking always will be there. The number of moles of electron involved in an oxidation process should be equal to the number of moles of electron in a reduction process. Here 12 mole is involved reduction process, oxidation only 4 mole of electron. That's why overall reaction of oxidation multiplied by 3, then immediately what you will get over here, 3P4 plus 24 H2O, and it will be converted to that 12 H2PO2 minus, and then 24 H plus 12 electron. Now this equation and this equation, if you now add it up, then what you will get over here? Now you look at 12 electron cancelled. And now after that, here P4 and 3P4, which is nothing but a 4P4. Now here you have a 12H plus in a reactant side, and product side if you look at 24H plus. So that's why product side effectively I will have a 12H plus. 12H plus will be their product side. Now come into the H2O. Here you have a 24H2O. Whereas product side anything is there? No, product side is not there. So that's why 4P4, here P4 and 3P4 is a 4P4 plus 24H2. 24H2. Now if you look at everything is, this side is completed. Come to the product side. Product side what is there? 12H2PO2 minus plus 12H plus, already I write down over here. And anything other thing is there? No other thing is there. So now if you look at over here, so the idea is over here itself, here I am putting 3P4 and P4, which is nothing but a 4P4, and here we are getting over here, if you look at 3 into 4, 12 H2PO2, and here pH3 we are missing. So that's why here already was there 4 pH3, that should be over here 4 pH3 over here. So now if you look at now these things, checking everything is balanced or not. If you look at phosphorus, 4 into 4, 16. Here 12 phosphorus and here 4 phosphorus, 16. Now what about hydrogen? 24 into 2, 48 hydrogen is there. So then immediately if you look at 12 into 2, here there is a 24, 24 into 12, 36, 36, 4 into 3, 12, 36 plus 12 is 48. 24 oxygen, 12 into 2, 24 oxygen. Overall charge this side neutral. This side you look at 12 minus and 12 plus is a neutral. So now the reaction is balanced in a what medium? Acidic medium, because in a product side 12H plus is there. If you want to do in a basic medium, what do you have to do? Here you need to add 12 OH minus. Here also you need to add 12 OH minus. And then 12 H plus and 12 OH minus will form 12 water molecule. And reactant side 24, you bring this side 24 minus 12, it will be there will be 12 H2O and there will be 12 OH minus and rest of the things will be there. That side you can easily balance these reactions. Is it clear to everybody? I hope everybody got the clarity how to balance the redox reactions by ion electron method as well as oxidations number method. If you want to get this type of video more and more, please comment to my channel, comments and like it, subscribe it for getting more confidence on the chemistry. Thank you very much. Thank you all. Thank you, my dear student.